Okay, are we ready now? Okay, so now I talked about how basically we can solve log equations by using exponentials and exponential equations by using logs. There are some, and I for a second you forgot about this. There are some that you don't need to switch them. Okay, there's these one-to-one properties is what they're called. Simple. Sides or an exponential on both sides, you can cancel them out as long as they have the. So here's some of the one b, and that equals log b of c. You can just, like I said, kind of cancel the two logs, because if those logs have the same base, then whatever's inside logs would have to be equal as well, right? To make those things both come out the same. So if this is the case, equals c. Whatever's inside the two logs, you can just take them out. Those are equal to each other and work it from there, which is usually a much easier problem to do. Likewise, if I had like, we'll say b to the m equals b to the n, well then m equals n. And they have the same base. If those two exponentials are going to come out the same, then what they're being raised to is going to have to be the same number too. So in this case, m would equal n. Okay. So let's work on a few that are using these properties. Like I said, these are the easy ones. Okay. If they're set up that way, you've got it where they match. So if we had something kind of like, maybe something like that, 6 to the 3x plus 1 equals 6 to the 4th. Okay, so somebody raise their hand, give me a first step how I can get this thing converted to solve it. Yeah. Okay. All right, well, let's start with this then. 3x plus 1 equals 4. Okay, like we said, bases are the same. Now, if it had been like 6 to the 3x plus 1 equals 5 to the 4th, could we do this? No, right? They have to be the same base, so we know they're going to come out the same, and then we can just go from there. So, yeah, so 3x plus 1 has to equal 4. Now it's easy, right? Subtract 1, divide by 3. What's the answer? X equals 1, yeah. Let's do some logs here then. Log base 2 of x plus 5 equals log base 2 of 3x. So somebody who has not spoken yet, raise your hand, tell me what to do. Yeah. Mm-hmm. Okay. Somebody else who has not spoken yet, can you give me the answer? Can you solve this real quick? Can you do that much in your head? Don't want to go that route with it. Instead of subtracting the 5, subtract the x. Okay, and so then, yep, you got it? Yes, Because then you're going to do 5 divided by 2, right? So which is 2.5. Yep. Doing that in your head at that stage, go ahead and write it out. It's fine. Okay? Just doing that for some people that maybe could do that. That's fine. You subtract the x to the other side, so it's 2x, and then you divide each side by 2, and you get 2.5. How about use this one-to-one property? Okay, what do I got to do first, though? Yeah, go ahead.
Oh,
Mm-hmm.
well, like, x 7 squared.
Okay. Okay, so we got to do that first, whether that's in your head or not. But so then we can do this one-to-one property like we did before. So 2 equals 13 minus. And then if we solve that, 13 minus what gives you 2? 11. Yeah, so the answer is 11. Natural log of 2 equals 2 natural log of x. How about this one? Can I use my one-to-one property for this one? If you know how. Well, all right, so what we said was, if you've got 2 logs that have the same base equal to one another, then whatever's in them is equal, right? Do we have that exactly here? Same base, but this is kind of screwing the deal right now, right? This 2. So what can I do with that 2 so it's not getting in the way? Yeah? Yeah, use that power property. Remember that? If you have a number in front of a log, you can bring it up, make it part of the exponent on the inside. So what we end up with x squared. Okay, so sometimes you might need to do that to kind of get around it. So now, cancel, right? Get rid of the natural logs and either 2 equals x squared. So how do I solve something like that? 2 equals x squared. Yeah. Exactly. It's going to be plus. Because remember, when you got to square root both sides, right? So when you square root both sides, you have to do plus or minus because it could be either way. And in this case, it's plus or minus the square root of 2. That one-to-one property business makes sense to you guys? You might have to do a little bit of, do a little trick to get it going, but once you've got it set up, then it's not so bad. Okay, and just match them up and go. Ones where this little one-to-one property might not work. So let's take a look at some exponential equations. And what do we got to do with these? All right, so how about let's see what work. Okay, say we got something like that. 3 plus 4e to the 2x equals 15. You know it's an exponential square. Up. We got to figure out how we can get at x to solve it. Okay? So, first thing you want to do is what's called isolating the exponential. Like e to the 2x is your variable, is x, just itself, okay? And think about to algebra 1. So what would be the steps you'd have to do to get just this piece right here by itself? So now we're at 12. And then divide by 4. So here's where we've isolated the exponential, okay? All right. And if we didn't know anything about logarithms, we'd be stuck at this stage right here. So what we can do, two different routes, and I'll show you both of them, and you can decide. Either you can take this and convert it back into a log equation, like we did right at the beginning when we first started talking about logs. How do we know what goes where when you take an exponential and make it a log and back and forth? Okay, we can go that route with it. Or there's this process of logging both sides of the equation. Okay? Over here, let's do the turn it back into a log way of doing it. Okay? So, what's the base of the log? Nope. E, right? And what kind of a log has a base of E? A natural log, okay? So, we're going to have to turn this into a so natural log what? 2. Okay, so remember doing that? Whatever's in the exponent is what the log is equal to. Okay? That's why we're doing this, because now we have a way to solve it. Okay? Natural log of 3, you got a calculator. Natural log of 3. Get up. We get. Can you decimal places, let's say? Two. And 3. So that's the turning it into a log way of doing it. It's kind of you're turning it into a log. It's a little bit easier where you don't have to remember what goes where in the log. Okay? There's some other things you have to remember to be able to do with this, but you don't have to remember that. What you do is take a look at the E, put that kind of log on either side. So you're going to log both sides of it. backwards. Instead of getting rid of the logs, I put them on. Okay? Now, log of e calculator. The natural log of e and be 1. What's the natural log of 3? Well, we did it over here, right? 1.098. This is kind of the same as that, right? Is with it, which you would rather do. Okay. Well, you can remember how to convert into a log. The first method, I think, is much easier. If you can't remember that, but you do remember your product or your power and can use that, then logging both sides is a little bit easier. It's about a 50-50 split with students in the past with these two methods. But solving some log equations, and then we'll be done. What can I make that equal to? Let's do -5. Okay, so 3 minus 1 equals -5. All right. So, again, the exponential. So, where should I start then to isolate the exponential? -3? Okay. Like that. Same thing. Okay? So, this way, it's kind of like -1 times 2 to the x minus 1. Okay? So what could I do to get rid of that negative then? Times by -1. Or divide by -1, depending on how you want to look at it. And that's okay. Multiply each side by -1. Okay, so now I got to turn this either into a log or turning it into a log. Can anybody tell me what that should be? Log base what of what for this particular one? It is always what it's equal to. If that helps, okay? Finish this thing on my calculator. How am I going to do log base 2 of 8 on the calculator? How did we evaluate logs on the calculator? Change a base formula, right? So what would change a base? Do those numbers or something. So okay, which is, yeah, exactly 3 in this case. And so what's x? All right, and then doing it. And I'm going to keep them common logs, because I can choose whatever base I want, right? And I can do common logs on my calculator. This way. Bring down the x. But you can do log 2 and log 8 on your calculator, right? Three divided by 0.301 should be 3, right? Still 4 for that one, too. How do you get 3? This divided by this. Do you see how this divided by that is 3? 9 divided by 3 is 3. 3 divided by 1 is 3. So the whole thing comes up to 3. Or you just do it on your calculator. It could give you 3. But again, both methods are fine. Whatever you want to do. So no, that's too big. Okay, just 2. So log base 3 of 5x equals 2. So you can convert this thing back into an exponential, doing kind of the same business we did with the exponential equations, just we have to think it backwards now. Okay, so can I get this one turned back into an exponential, what it should look like? Yeah. Base of 3. 3 raised to the 2 equals what's in the log, 5x. Okay, well, what's 3 squared? 9. X is going to be what? That, now, this one, you can logging both sides technique. This one you can do like you can, I don't know what the verb is, but you can do an exponent to both sides. Not a lot of people choose to do this, but whatever the base of the log is, I use that as my base of my exponential, and I just put both of them with a 3 down there. Now, there was a property we talked about over here that we can do with this one. 3 raised to the log base 3 of 5x. What does this thing turn into? Just 5x. These guys cancel each other out. So I'm looking at 3 squared. Okay, see how I'm just right back to here now? You can do it that way. Most people find that overly confusing. It works. And we end up with this doing it that way. But it's a thing. Okay, let's do one more of these. Then I think the one, the log was already isolated. In this particular one down here, we haven't done that yet. Always the first step is to try and isolate the log if it's not already there. So if you have log of something equals a number, okay? So what's the first step I got to do here to make sure that happens? Add the 10. Yeah, I have to do that first. One plus 3x equals 3. Oh, 20. You don't want it to be a 23 because it's going to be huge. No, that's it wrong. Sorry. Make it. It should be a plus to start with. So that's 3. Okay. So what do we do? Yep. Remember? I'll make sure everybody heard that because there was somebody in the back who was talking. Common of 10. So if we're changing it into an exponential, it's 10. Keep going, Mr. Ryan. Yep. Got it. And what is 10 to the third? So 1 equals 1 plus 3x. Okay. What's the answer? So, think we can do this stuff? Okay, let's get after it.